That's it. And based on eigenvalue, we just let it then run greater than 1. Okay, if in your research study, for example, in your final presentation, you really find that hard time to run, go to 3, something like this. Otherwise, normally, or generally speaking, we will use this one. This is the academic way, okay? And continue, and rotation, we use a varied mass.
Do we need to check
and then
Do we need to check the square plot? In the expectation.
square plot. Yeah, don't forget, as I forget it in this case, square plot, all right? And if you are familiar with that, because we know there's a table, so you need to check the square plot, okay? So what I suggest is, you are student, new learner, and you can follow my way. Rotation, varied mass, and the score, you don't need to do anything. And option, check these two, okay? And let me check again. Okay, and extraction, all right. And then rotation, varied mass, and then score, option. Okay, here we go. Now we have a KMO, so it is significant, right? And then you put the KMO t-test, the value of Pareto t-test, and significant. What I mentioned is over here. KMO equal to, in this case, what is KMO? 0.601, all right? And then what is Pareto test, chi-square? It is 948.983. And then what is significant at P? Here we go. We have a P equal to 0, 0, 0. Okay, 0.000. Okay. And then you need the eigenvalue. It's here. 1, 2, 3, 4, 5. We have 5. Okay. So you just put 5 in your table. Okay, and put the eigenvalue for each, and then put your item, and we have item for here. Rotated component matrix 1, 2, 3, and 1. But this case is not really. The result is not really beautiful. Okay, so I will provide you okay later, and also for this one combo alpha. All right, so for this case, for example, we have a rotated component matrix. So for the first factor, we have 3, right? How to tell the first and then second factor? How to tell? When it goes down quickly, or it become this one. This is not good example for here, and for like this. For here, here, when it go down like from 0.801 to the lowest score 0.340, and then another one show up, the biggest one, that 6A, and we say this is belong to the second component. Again, when the highest score even than the second one show up, and we will say this is third component. Okay, same, 7. All right, so it's not difficult to identify unless there's some score 594 and 534, and we call this is cross loading, because this item really cross the factor 1 and factor 2. And in this case, we will delete this one and rerun. But we will do this next week. All right. So now we want to solve the issue of combo alpha. In this case, if we use a smoking case, we in our item factor 1, we have a 16, 17, 18, 14, 11. Let me recognize and write down it. So we have from 16 to 15, right? So how to calculate the Kwamba alpha? Here's a scale. It's a reliability analysis here. And since we have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 items, so we need to include 11 items over here. Again, analyze, scale, reliability, analyze. And the item we have is 16, and second one is 17, and 18, 14, and 11, and 7, and 10, 3, 9, 19, and 15. Okay, this is all what we have. And we will see this Kwamba alpha show up. This is Kwamba alpha 0.804, and you just put the Kwamba alpha as here, because as I mentioned, we use this one, smoking, and we found out there are 11 items over here, and you just go to analyze and scale using a reliability analysis, and then include 11 items inside. After including it, and then click OK, and you can get the Kwamba alpha. This Kwamba alpha means it have a higher reliability. You know, the group with the smoking behavior, they still can work very well. This means reliability and Kwamba alpha. Okay, Kwamba alpha starting from. Okay, so now you guys know how to fill out everything, like agent value and rotated of percentage variance Kwamba alpha, and even here. And of course, after you knowing this, you can check out your article which I gave you. Analysis of influence factor like this one. This is used the factor analysis, and you can see when people draw them like this. And in the future, when we move to the cluster analysis, remember, factor analysis, we only use a variable. We define a factor and run a regression and predict their smoking behavior. This is what we are going to do in the regression. Okay, just like the group in the future using the regression. Alright, so in this case, you can also find out there are a factor analysis table. Like this, KMO, right? KMO. So you can see it's significant, and chi-square is pretty high, and KMO is pretty high, and they are factor analysis, factor loading, eigenvalue is pretty high. They are all larger than 1, and variance is brand, and Kwamba alpha. See, everything is provided over here, and you just see the first factor they call the cultural attractive. Why? Because the name is based on the first item or second item or combine it, whatever. Okay? And please read the article related to the factor analysis. And now, I believe you can easily to assess what they are talking about. And then in the future, if you don't know how to write your results, just read more paper and get some more idea and write up your conclusion. Alright, so after go back home, I will upload one cases